The force due to gravity by a mass at the origin of R2 is given by the following force function. The vector f of xy, the force vector, is equal to a constant divided by x squared plus y squared to the power 3 halves times the vector negative x negative y. And the constant k is a positive constant that depends on the masses of the objects involved. So we're going to determine the work on an object by this force, this gravitational force, as the object moves in a semicircle from one point to another. So we have an object at the origin, maybe think of that as the sun, and that's going to be exerting gravity on a point that's moving in a semicircular arc around it. Maybe think of that as the Earth. And we want to find the work that's done on the object by this force. Now, this is the origin, and so at any point in the travels of the object, this vector is pointing towards the origin. And the origin will be at the center of the circle. The circle, this is 3 units here, so the circle has a radius of 3. This is 3 units. This is the number -3 on the horizontal axis. This is a semicircle at the origin, radius 3. So one little factoid about a semicircle, let's redraw it to make it maybe a little bit more clear. Let's redraw our semicircle a little more accurately. That's not much better. But at any point, the vector that points towards the center and the tangent vector to the circle are going to be perpendicular. And that means that no work is going to be done by the force, because as you move perpendicular to a force, the force is not doing work on the object at all. So we should get an integral here. When we can calculate our line integral, we should get 0. Since we're moving perpendicular to the force, no work is done. Work is done by a force when you move towards in the direction of the force or in the opposite direction of the force, or in any with any component in the direction or opposite direction of the force. And perpendicular motion has no component in the direction of the force or in the opposite direction of the force. Okay, so we expect an answer of 0. Let's calculate our work. Using a line integral, it's going to be the integral along the path of the force dotted with dr. And what this means is we're going to be integrating from A to B. We're going to parameterize our curve r of t as x of t comma y of t. And then for x and y here, we'll put in x of t and y of t, whatever they turn out to be. And then dot dr means dot the tangent vector dt, the tangent vector to the path c. So we need to parameterize our semicircle, and that's given by, it has a radius of 3 centered at the origin, so simply 3 cosine t, 3 sine t will do the trick, where t goes from 0 to 180 degrees using radians, 0 to pi. So our integral is integral 0 to pi, and x of t we could see is 3 cosine t, and y of t is 3 sine t, which means x squared plus y squared will be 9 cosine squared t plus 9 sine squared t. Factoring out the 9, it's 9 times 1, so it's just 9. So we have here k over 9 to the 3 halves, which is 27. Take the square root of 9, 3, and then cube it. And then we have here the vector negative x, negative y. X is 3 cosine t, so negative 3 cosine t. And negative y is negative 3 sine t dotted with r prime of t. See, this dot product is going to be 0 because these are perpendicular. We'll see that in just a second. R prime of t is negative 3 cosine t, negative 3 sine t, comma 3 cosine t. And that goes here. So negative 3 sine t, 3 cosine t, dt. And what is this dot product? Negative 3 times negative 3 is 9, and we have a cosine t and a sine t. There's cosine, there's sine, and then plus. Negative 3 times 3 is negative 9, and we have a sine and a cosine. Sine t, cosine t, and these are opposites, so this dot product is 0, and so we are integrating from 0 to pi, a constant, times 0, so we're just integrating 0, and that'll give us 0. So when an object is moving perpendicular to specifically a force of gravity, then no work is done by gravity. In order for gravity to do work, you have to either be moving to some degree towards, you have to have some component of the motion either towards the other gravitational object or away from the gravitational object, the massive object.